Okay, shortcut today, and it's just beautiful how it all goes together. You guys are gonna really like it, and the cool thing is you're gonna understand the whole thing. Okay, and so again, so this is a question comes up. Everybody asks it. They say, "Why don't you just show us the shortcut right away?" This is exactly what I'm telling you. Is that if I just showed you the shortcut is basic enough where I could teach my 3rd grade daughter how to do it. Okay. Now, again, I've had students, I mentioned my cousin, didn't I? All she learned was shortcut. Got to college, math major, done. She said, my teacher, my calculus professor at college is making me learn all this limit as h approaches 0 stuff, and it's like, why do I have to do that? I know that the derivative of 3x squared is 6x. Why do I have to do that? I said, well, I said, sorry, but you did not learn calculus. I said, honestly, we could teach that to 8th graders, and you don't understand what's happening. So let's understand how we get it. We'll do the basic ones, and then we'll do the power one, and that's where we'll go from there. If you have f of x is equal to a constant, what is the slope of a constant? 0. So if you have a constant, say for example, let's say you have y equals 8. That's a horizontal line that goes through 8, right? So the derivative of 8 is 0 because the slope is always 0. Let's say you have a function equal to x. Y equals x. If we take the derivative, we get y prime is equal to, what's the slope always of x? It's 1. What if we had to say y is equal to 6x? What's always the slope of that line? 6. So y prime is always equal to whatever the constant is. Very good. So now we get to, what if we took x and we raised it to the power, like x to the 4th? What's the derivative of x to the 4th? So that's where you got to insert a new, somewhere else. How about this? If you want to write this down to follow along, you can. If you don't want to, that's fine, but I do need you to follow it. So we have f of x is equal to x to the nth. Because the first time I saw this, I didn't really know what my teacher was doing, and now I fully see it because we've covered all the material we need to. So if I want to find the derivative of f prime of x, what we have to do is we have to use the limit as h approaches 0 of what? X plus h to the? At this point, you're like, I got 3 variables. Scary. Minus x to the n all over h. Well, let's just look at it from the outset, you guys. I got a minus x to the n. In front here, I'm going to have an x to the n, right? They will cancel. But let's work this out just a little bit so you can see the beauty behind it. Do you remember when we did problems like this? X plus y to the 4th power. You remember that? And you got x to the 4th, x to the 3rd, y to the 1. And we use Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Let's see, that's 0, that's 1, that's 2, that's 3. So 4th is 1, 4, 6, 4. Oh yeah. All right, yeah, okay, yeah. So that's the 4th. There we go. It's like, what the heck is happening? All right, Pascal's triangle doesn't work anymore. It all fell apart one day. All right. So then we put it back in there. So we've got 1, we've got 4, which always ends up being that power. Look, 4, 3, 2, 1, right? The first coefficient is always the same as the power that you're working with. And we've got 6, we've got 4, we've got 1, yada, yada, yada. That was a piece of cake, right? Upside down. Well, let's check it out if we work it out like this. equals the limit as h goes to 0 of, what's the first term going to be? X to the n. Then I will have an x times x to the n minus 1, very good, times h. What will be the coefficient? N. Does everybody see why? Yeah, we said whatever the power is, that's what that first coefficient is going to be. That's the way Pascal's triangle works and the binomial theorem works and everything like that. Plus, oh boy. See, you do calculus too much and the smart board blows up. All right. The dumb board. All right. Okay, so let's try again. Plus, do we know what the next coefficient is? Not necessarily, and it actually really doesn't matter. We have, I'm just going to write coefficient 1. We'll have x to the n minus 2 and h to the 2. And then we would have x to the n minus 3 and h to the 3rd. And now we continue all the way down until we got to h to the nth power. Is everybody okay with what I wrote? If there's a question, we can ask. We've almost got it. That's the limit as h approaches 0 of. Does everybody agree that the x to the n's cancel? We knew that from the beginning. And so what we have is n times x to the n minus 1 times h plus some constant times x to the n minus 2 h squared. I'll even write another constant just for good measure so we all get the point. That's going to carry on until we get to h to the n. So in that step, all that happened was we canceled the x to the n's. Now we take out an h, right? So how about instead of writing the step where I factor it out, how about we just reduce the h powers all by 1? Is everybody okay with that? So now we have the limit as h approaches 0 of, this first one will be n times x to the n minus 1 plus c sub 1 times x to the n minus 2 times h plus c sub 2 times x to the n minus 3 times h squared plus dot 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 plus h to the n minus 1. Isn't it beautiful? Look. Because we divided this h off, so therefore it reduces the power of all the h's by 1. Notice that, is it now okay to plug 0 in for h? Yes, because I'm not dividing by 0. And if I plug 0 in for h, all of these have an h, right? And if all of them have an h, they'll all be 0. And so what we end up with is f prime of x is equal to n times x to the n minus 1. What does that mean? It means if f of x is equal to 10x to the 8th, then f prime of x is, drop the 8 down in front. What is 8 times 10? Reduce the power by 1. That's it. Yeah. let's actually. We did, Larry. We did it. We did it all. We did it for every polynomial right here. We just proved it. Okay, so Elizabeth asks a good question, you guys. Okay, Elizabeth asks a good question, and this is what you're going to learn in calculus. Is as soon as we get a shortcut, you kind of thought, it's like, well, we're done. I mean, it's like, what else could there possibly be to calculus? We can now take the derivative of everything, right? I'm just going to write down a couple, okay? How would you take the derivative of this, though? No. Because this rule says in order to take the derivative, you would have to multiply this out 23 times. And then apply your power rule. So as soon as we give you one shortcut, we can find a lot of functions that, well, that would be pretty difficult, right? Now there is a way to work around this too, and it's pretty cool. Here's another one. What about this? Well, that's a function. You're going to reduce the power by 1 and multiply? No, you're not going to. What about how about this one? How about the natural log of x over e to the x? How about what about that? You know? No, I'm just saying that, you know, as soon as you find, you know, yeah, life is beautiful right now. We know how to take the derivative of polynomials. It's great. But the world does have more difficult functions. And functions that actually come up a lot in real life. And so we'll eventually work with those. Yeah, real life. Yeah. You're living in a pretend world right now, Hannah DeVries. Alright, so let's finish off the notes. And we'll give it a shot. The derivative of x to the nth. If y is equal to x to the nth, y prime is equal to n times x to the n minus 1. So, this is a very happy time for us. We are going to actually also do these. Okay, if you have f plus g, you can separate it to f prime plus g prime. You can divide up the addition. And if you have subtraction, you can just do f prime minus g prime. However, you can't do that with multiplication and division. So that's what we'll talk about tomorrow. But for today, let's just flip it over to the next page and let's practice what we've learned on some of these problems. And what's so cool is that every time we do this, what we're doing is we're applying the limit as h goes to 0 of f of x plus h minus f of x all over h. But we're going to do it really quickly. So it's really cool. What's the derivative of 5? 0. So f prime of x is equal to 0. What's the derivative of negative 8? Negative 0. What is the derivative of? And I'll show you guys how it works with the power rule, okay? If you have negative 8, that's times x to the 0 power, right? That's what it is. So if you drop the 0, you get 0 times negative 8 times x to the negative 1. Well, 0 times anything is 0. And for like 4x, what's going to be the derivative? Yeah, here's how it works in the power rule. You have 4x to the 1, and you bring the 1 out front. 1 times 4x to the 0. What's anything to the 0? So you have 1 times 4 times 1, which is 4. So you can see it does work out with the power. A lot of times people forget about the constants or the linear and how they work out like that. How about this one? Negative 3. What's the derivative of 5? So I just don't write it. Now this is exciting because you remember this one. You used to say is, I'm confident I can figure that out. I wish it wasn't so much work. Well, now we're just going to fly through it. What's the derivative of 5x squared? 10x to the 1. What's the derivative of 10x? 10. And what's the derivative of negative 3? 0. Look at that. Megan, you look like you have a comment. There's something you're feeling inside. All right. Sometimes, if you see a square root, it's easier if you write that as x to the 1/2. So let's do that. So f prime of x is equal to, what's the derivative of 8x to the 5th? 40x to the 4th. So every time you do that, you just have to stop to say, whoa, I did that. That quick. Because now you can walk up to next year's pre-calc class when they're just starting out. They're using the limit as h approaches 0. You'd be like, yeah, you can say, I know how to take the derivative of that already. You know, and it's, you know, you just show off. Come back on the, minus, what's the derivative of 3x to the 3rd? 9x squared. Ooh, 1 over x squared. Maybe I should rewrite that as x to the negative 2. Okay, so I gotta rewrite it in power form all the time. What's the derivative of x to the negative 2? Negative 2x to the negative 3. You gotta subtract 1. This is the biggest problem that people have. And you guys, you gotta get used to that, because in a couple months, you're going to be finding antiderivatives. You're going to be going the other way, and you're going to be adding one. So, yes, we'll rewrite it as 2 over x to the 3rd. Very good. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2. Oh, I'm sorry. Yep, you're right. It's a minus sign. Very good. I'm off my game today. It's my mom's birthday, though. She was born at noon, so my 4th hour class, we're going to call her at noon and sing happy birthday to her. Yeah. Well, somewhere around there. She doesn't really remember. She was pretty young. So let's. You can't leave it like that, everybody. If you leave it like that, it's wrong. You got to write it 9x squared minus, as Hannah said, 2 over x to the 3rd, and I'm going to rewrite this as minus 1 over 2 roots of x. I'm going to write that as. Very good. You can't leave a root of a number on the bottom, but you can leave a root of a variable on the bottom. Okay? All right. G. Always got to rewrite it in exponential form, people. F of x, power form. This would be negative 3 over x to what power? 5/3. So that would be f of x is equal to negative 3 times x to the negative 5/3. So now at this point we can execute our derivatives. And as soon as you say that's difficult, just remember we could make you do the limit as h approaches 0 instead. Right. That's much more difficult, isn't it? So let's take joy in the fact that although there's some fractions, although there's some negative exponents, we can handle that. So f prime of x is what? What do I do with that exponent? So don't be afraid to write it all out, people. Don't be afraid to just write it all out. Make sure you get it correct. Times negative 3 x to the, we're going to subtract 3/3, so that's negative 8/3. What do you notice about the 3's? They cancel, so we have f prime of x is equal to, it's just going to be 5, right? You have 2 negatives, so we've got 5, and it'll be over x to the 8/3. You can leave it like that. However, if you want to write it like this, if you want to write f prime of x is equal to 5 over the cubed root of x to the 8th, that is technically not reduced. Why? There's a perfect cube. What's a perfect cube? You could take out x to the 8th. X to the 6th, and it reduces to x squared. So technically, you would have to write this as 5 over x squared cubed roots of x. So you can either leave it like this, or you can leave it like that. Either one is up to you, and your book sometimes has both situations answered that way. Oh wait, I'm sorry. Squared. I'm sorry. Squared. I have a negative 5/3 times a negative 3. Is this one written in power form? It sure is. So I don't have to do any rewriting. F prime of x is equal to, I bring the 6 over 7 in front, times negative 2/5, times x to the negative 1/7. Yep, so 6/7 minus 7/7. And I get this. And so now we have negative 18 over 30, oh, I'm sorry, negative 12. I'm really off today. Negative 2/5 times 6/7. So that's a negative 12 over 35 times x to the negative 1/7. So that would be 1 over x to the 1/7, right? Times 1 over x to the 1/7, or the 7th root of x. So I suppose we could leave this as negative 12 over 35 7th roots of x. I think your college algebra teacher was supposed to review some of them, but I know you guys had an intense dealing with radicals during your junior year. So, all right, we can do a little bit of work with them. All right, f of x is equal to negative parentheses 1/3 x to the negative 2. What do I do? We're going to take this negative 1/3, or this 1/3, we're going to take it to the negative 2 power, and we're going to take x to the negative 2 power. Again, if you have multiplication on the inside here, we need to take both to the power. If we take a fraction to a negative power, what can we do with that fraction? Flip it. You end up with 3 squared. What's 3 squared? So this is actually negative 9 x to the negative 2. That's what that is. Now, let's take the derivative. Yep, we'll eventually put it down, but not yet. We haven't taken the derivative. What's the derivative? 18x to the negative 3, which is 18 over x to the third. And you guys, I'm taking you through some of the harder examples. You're not going to see, most of the time, most of the time you're going to be doing stuff like letter E. It's going to be like, okay, take the derivative, done. You know, well, you should be prepared for any of it. And as I told you guys, I think the median score in your last test was 32 out of 31. Sounds like your teacher needs to start making more difficult tests. So we'll okay. Yeah. Okay. We'll save the fun one for last. We'll do K last. But look at J. J's tricky. Does anybody know why J is tricky? Yeah. And so what you really need to do is this, okay? We don't have anything that says you could take 5x to the 1/2 and take the derivative of that by moving the 1/2 out in front. So what we need to do is you have a great property that uses exponents to be able to solve here. So, or using radicals. So we have f of x. I'm going to rewrite it like this and see if you guys are okay with this. You're going to have a coefficient here of the square root of 5. And we will have a variable of x to the 1/2. Does everybody see that? Now it looks like a power form that I can work with. So that way, instead of taking 5 times 1/2, it's really the square root of 5 times 1/2. Minus the root of 3. Isn't that just some constant? That's no big deal. Plus x to the 1/2. And so this really isn't all that bad. Megan, do you have a question? Okay, so we drop the 1/2 in front. So we get square root of 5 over 2 times x to the negative 1/2. What's the derivative of negative square roots of 3? 0. And then what is the derivative of x to the 1/2? Now, some of you guys remember that we just did that problem. We got 1 over 2 roots of x. You remember that? Today we did that. Yeah. So doesn't this simplify to square root of 5 over 2 roots of x plus 1 over 2 roots of x? Or in other words, square root of 5 plus 1 over 2 roots of x. That's my derivative. That's the instantaneous rate of change at any given point of x, and you did it within a matter of a minute and a half. So I put this one at the end. This is really an easy problem, isn't it? It's really an easy problem. It's just no. Before you do it, you got to take it all in. Okay, you got to say to yourself, imagine if we were to do the limit as h approaches 0, and you were to FOIL out the x plus h 7 times. And you said, oh, well, I can FOIL it out 7 times because I know Pascal's triangle. Great, good for you. Because then you're going to do it 6 times, then 5 times, then 4 times, then 3 times. Exactly. But we can look at this type of problem, and we can take the derivative so quickly. What's the derivative of 2x to the 7th? 14x to the 6th? 18x to the 5th? 10x to the 4th? 4x cubed? Look at that! Instantaneous rate of change in 11 seconds. Boom! But you do understand, everyone. You do understand. And I know I have a bright daughter. Okay, I know that she's a sharp girl, but you do understand that I could take that home. I could teach her to do that. She knows how to multiply. She knows how to add. Now, I couldn't teach her the radical stuff, but honestly, that is not calculus. This, because you were able to understand it, this is the calculus. This is what we did to help you get to the rule that is so nice and easy to use. So that's the idea of calculus. Big ideas. Big ideas. I got a nice worksheet for you.